The second part of our video is finding the incenter. This is also our second special segment. An incenter is just the intersection of three angle bisectors. Okay? Remember, to find an angle bisector, you just take an angle and you bisect it. You'll need a protractor for this, so there's a good chance you guys don't have it, which is okay, so I'm going to show you how to do it. You just need to know that the incenter is the intersection of the angle bisectors. So we line this up here to find this angle. This angle is 100 degrees. This angle ICN is 100 degrees. So if I'm looking for the angle bisector of that, would be 50 degrees. So what I'm going to do is I'm going to make a little mark at 50 degrees. See, there's my 50 degrees, because I want the acute version, so I use the top one. Obtuse, see it's bigger than 90, that's how I know it's 100 and not 80. It's larger than 90. So if I want 50, I go to the 50. Then I'm going to take, I would take my ruler. If I were you guys, I would take my ruler and I would draw it from the vertex through that 50 degrees. Okay. So that is the angle bisector, and I can label it. Okay. Next, it doesn't matter how you go about it, just make sure that you have your target or your bullseye, your crosshairs on the point, and line up this line here with the side, right? And right there, we're about 32-ish, 32. Actually, let me see. Oh, there. Oh, yeah, 32. So that means we need 16, right? Oh, no, excuse me, 52. So we need about 26. So if from 20 to 30, you look for that long line. You look for that long line that's in there. That's your 25. So if I want 26, we're a little bit over. And again, we are just estimating. So if you're a little off, that is okay. Right? You can be off by a degree or two. Right? You can't be off by like 5 degrees, but a degree or two is fine. Right? And then last, we will have, so bisect I. Oh wait, forgot we got to mark it so you know that it's the angle bisector. So here, we said that's 52, right? If we said that's 52, this should be about, let's see, we had 152, 28. So let's get it on here. If it's not 28, we did something wrong. And that's about 28 because the triangle sum theorem. So 28 will give us, we need to be at about 14. So 10, 15, be about right there. Get our line from here. And as we said, it might not be exact, but we're looking at about right there is our incenter. That is the incenter. And if we're going to estimate it, it's about that might be like 2.1, 2.1 actually. That would be approximately the incenter. Okay. The incenter comes from the vertices. I'm going to show you in the next slide, but the incenter comes from the vertices, and it's equidistant. It's equidistant to each side. Okay, so here's the concurrency of angle bisectors. We bisect each angle, they intersect at the incenter. This is the incenter, okay? That incenter is equidistant from each side. Remember, the circumcenter came from the side and is equidistant to each angle. The incenter comes from the angle and is equidistant to each side, right? Equidistant. Right. So that's what you need to know about the incenter. It's created by the angle bisectors, and the incenter is equidistant from each side. Where the circumscribed was circumscribed around the triangle, the incenter is the circle is inscribed in the triangle. And that's why this incenter is also the center of the circle and equidistant. Each radii is the same, right? Each radii is the same length. So therefore, because it's inscribed inside, that makes the incenter equidistant from each side. Well, let's review. How would you show it's equidistant from each side? So if this is our point, what would I have to do? How would I find the distance from this point here to this side? Anybody remember? Perfect, yes. You drop a perpendicular. So we would drop a perpendicular from here. We would drop a perpendicular from here. That's not perpendicular. Should have put out a protractor, but we're just estimating for right here, so probably be about right there. You would drop your perpendiculars. You'd have to find the equation of this line and this line, find them where they intersect, just like we did last section, right? Find where they intersect. That's your point of intersection, then find the distance. We will not be doing that, right? We will not be doing that for incenter. The incenter, all you need to know is you have the incenter, it's the intersection of angle bisectors, and it's equidistant from all sides. That's what we need to know about the incenter. Okay? Pretty easy one there.